All right. Welcome, Wilson students, algebra students. So we're preparing for the Algebra 1 Unit 3 exam. It's like chapter 4, 5, and 6. Okay, so here we go. How do you rewrite an irrational exponent as a radical? So a rational exponent, a rational number is like a fraction. So you see that fraction is a over b. So we change it into a radical. X, that's the base. The b, that's at the bottom. That's going to be the root. The root is at the bottom. So that's the b. And then it's a whole thing to the a power. So b goes in here, x goes here, a in here. Notice that the denominator is b. That's in the root. The root is at the bottom. So with this one, the 5 is not to the power of a over b, just the x. So we have 5 times the radical, that's the x. So a, you can put it here, and then b, you can put it there. Now, this might throw you a little bit that I put it here, but you can also rewrite it as 5, and then there's x, and then there's b, and then the whole thing to the a power. So the top or the bottom, it's all the same. All right, so really, we need to know order of operation. All right. So first you have to do what's in the grouping symbol, the parentheses. And then we do what's in the exponent. And then we do multiply and divide. Now the thing with multiply and divide is that we go left to right. So left to right, whoever is first. Sometimes divides first, sometimes multiplies first. Depends on which one. As we go left to right. And then last we go add or subtract. But that's also left to right. So sometimes add is first, sometimes subtract is first. Depends on what order it's in when you go left to right. Okay, there's order of operation. Number 3, what is the value of each expression in words? Well, I think this one is just 7 times the square root of x. So that's the square root of x. This one is going to be the cube root of m divided by 9. Notice I didn't put m to the 1. It's really not necessary. You can put it there if you want to. All right, so now we got to talk about the rules. What is it called? The rules of exponents. So the base is a. The base is a. It's the same base. We add the exponent. So it's a to the m plus m. That's the product rule. Product means multiply. Now quotient means to divide. So when you divide, it's the same base. You're going to go m minus n. The top exponents minus the bottom exponents. And then the power rule, a to the m to the n power. So it's just a to the m times n. You just multiply it. And then the thing with the negative exponents, we really don't like the negative exponents, so we do what is called the reciprocal. You know, we flip it back and forth. So now it's 1 over a, but it's going to be to the positive m power. So you can see the a is now 1 over a. That's the reciprocal. And then the positive exponent is the m instead of negative m. All right, so rewrite each expression as a single power. So this is like the product rule. So what we do is that we add the exponent. So it's going to be 3 plus 8 plus negative 5. So 3 plus 8 is like 11. 11 minus 5 is like 6. So there's your final, x to the 6th. And then, let me see, with this one, we should probably do it in a couple of passes. So when we multiply, we add the exponent. So 7 plus negative 1, well, I think that's a to the 6th. And then, now what do? We subtract the exponent. So it's going to be a to the 6th minus 2, or a to the 4th power. All right, and then with this, there's a couple of ways of doing it. I'm going to go the inside first. So it's going to be x to the 8. Now 8 minus negative 4. So that took care of that. That's to the second power. Now 8 minus negative 4 is actually 8 plus 4. So that's going to be x to the 12. And then the whole thing to the second power. So this is like the power rule where we multiply the exponents in. So that's going to be x to the 24. Then let's take a look at this mess. Let's do the inside first. So x to the negative 9, x to the 13, we add it together, and I think we get like 4, don't we? So x to the 4th divided by x to the negative 5, and the whole thing to the 4th power. And then, remember 4, we're going to minus negative 5. But remember, minus negative 5 is like plus 5. So that's going to be x to the 9. And then the whole thing to the 4th power. And then this is a power rule, so we just multiply 9 times 4, that's like 36. So x to the 6th, 36. There you go. Well, I hope that was easy. Let's continue. So let's go to number 6. There we go. So given the graph and exponential decay model, how can you write the exponential equation? So you can see that it's something like this, and then the beginning value is like a, and then there's a decrease. So the equation, the initial is a, and then it's going to be 1 minus r, and that's to the t power. Sometimes it's to the x power, but it's all the same. So that's your x, and that's your y, and that's your rate of decrease. And 1 minus r, well, that's your decay factor. All right, so for number 7, the graph below shows the value of a new car for the age of the car in years. If V is the value of the car in thousands of dollars and T is the age of the car, write the exponential function. Now you'll notice that at time 0 is 32,000. So that means at the beginning, the car is at 32,000. And then the year later, it's at 27.2. So we can find this decay factor by looking for what is called the ratio, the common ratio. So if we take 27.2 and we divide it by 32, take out my calculator, 27.2 divided by 32, the previous number, you get 0.85. So it's going to be 0.85 in here. Now what this means is that brand new car, $32,000, and then every year it keeps 85% of its original value, of its previous year value. So it lost 15% per year. Oh, and I've heard that it lost 10% per year, but now it's saying it's 15. All right. And then last thing is that it's to the t power. So here's your function. So that 0.85, that's the second year divided by the first year. All right, so number 8. Number 8 says, what does it say? It says, the graph below shows the number of followers a celebrity has on Twitter for a number of days after making a regrettable post. If F is the number of followers and D is the number of days past the post, write an exponential function. Now that, what is that? That's 50. So the guy starts out with 50. Now, this is a day later. It's at right here. That's 40. So like we did at the other example, we took to find the ratio. The ratio, we're going to take, that's 40. And then we divide by the previous year, that's 50. So it's sort of like this. It's at the beginning, there's 50. And then a day later, it's down to 40. So you take 40 divided by 50, you get 0.8. So he's keeping 80% of his followers. So he's losing 20% per day. All right. So if that's the case, then it's going to be 0.8. And then T is for days. So if you want to find out, on the 5th day, you just replace that with 5 and then you work it out. Anyway, there's your function. Okay, let's go to the second page, number 9. Given the exponential function, how can you tell if it's exponential growth or exponential decay? Now, usually the function is a times b to the x power. A is the initial amount, b is the growth or decay factor. So if b is greater than 1, then it's going to be growth. But if b is greater than 0 but less than 1, so b is like a number that's between 0 and 1, like 0.5, 0.6, it's like 50, 60%, then of course it's going to be a decay. So you look at the b, if it's bigger than 1, it's growth. If it's between 0 and 1, then it's going to be a decay. All right, determine which of these functions represent exponential growth and which represents decay. So here is the initial number, and this is your growth or decay factor. Now that's 0.4. So 0.4 is between 0 and 1. So that means it is decay. It's keeping like 40%, so it's losing like 80%. Okay, so there's your A and here's your B. Now 5 over 4. 5 over 4 is 1.25. Of course, that's greater than 1, so that must be a growth factor. So you start out with like 1/4. So you start investing like a 1/4. And then your rate of growth, it's 1 plus the 0.25, so you're actually growing at 25%. Okay, that's pretty good growth. Alright, so here is A and here is B. So if this was an investment deal, you started out investing at $3. And then every day, I don't know, you make it grow by 5, you multiply by 5. So by 5, of course, it's greater than 1, so that's, my young friends, is a growth factor. Okay, so there's A, you start at 45 cents, and 1.35. Of course, 1.35, it's bigger than 1, so that's a growth factor. So you're growing like at 35% per year, starting with 45 cents. And then that looks like A, 7 over 4, or like 0.75, 1.75. And then that is your B, and it looks like it's doubling. So 2, of course, is bigger than 1, so it's growth. So you start out with $1.75, you're doubling it every year or so, and then that's a +2. So it just means that you shifted 2 units to the left. 2 units to the left. I know it's plus, but it's to the left. It's backwards. All right, let's go to number 10. Now it says define the transformation of the graph produced by each of the variables. Now we started out f, that's the original. So the negative f tells you that it's reflected, it flipped, it reflected across the, what is that when it's displayed? That's the x-axis. Okay, so that tells you it flips. Now that h tells you that it goes right or left. And it's opposite of what you think. You see that negative sign? That's built in so that it flips everything. So when you have a negative sign, that's actually to the right. Positive sign is actually to the left. Yes, I'm aware it's backwards. Deal with it. And then finally the K, that's on the outside. And that tells you it's going to shift up or it's going to shift down. And it's exactly what you think. So positive makes it up, and then negative tells you that it clicks down how many units. All right, number 11. All right, we're doing good. Number 11. Give it an explicit formula. How can you write the first 4 terms? Now, what is the meaning of explicit? I'll give you an example. Like y is equal to 2x plus 3. So a sub 1, that means it's the first term. It's going to be 2 times 1 plus 3, or 5. A sub 2, you just put 2 in place of x. So 2 times 2 plus 3, which is 7. And then a sub 3 is going to be 2 times 3 plus 3, which is 6 plus 3, that's equal to 9. How many terms is that? That's first term, second, third. So last one, a sub 4. That's going to be 2 times 4 plus 3, that's 8 plus 3, that's 11. But maybe you already figured out that it starts out, the first number is 5, and then you just add how many? Add 2. Notice the slope is 2. Alright, so now what? Given the recursive formula. Now recursive means you need the previous number. So it'll be like a sub n is equal to a sub n minus 1. Let's say plus 5. So what that means is that to find the 7th number, you need the 6th number, and then you plus 5. Oh, so that means you need the previous number. So that means you need the first number. We don't know what the first number is, so I'll give it to you. Let's say the first number is 10. Then that means to find the second number, you got to find the first number, and then you add 10. Now, the first number, I already told you. No, not at 10, at 5. There's your rule right here. I forgot about the rule. Now, the first number, I said, is 10. So that's going to be 10 plus 5, or 15. So to find a sub 3, you need a sub 2, and then you plus 5, just like the rule here. And a sub 2, we already know it's 15. So plus 5, and that's going to be 20. Well, everything is plus 5, right? So the fourth number, you need the third number plus 5. So that's going to be 20 plus 5, or 25. So recursive means you need the previous term to get the present term. But the explicit, you just need to plug in, whatever x or n is, you let in 5, that means the 5th term. Alright, number 12. For each pair of explicit and recursive formulas below, find the first 4 terms of the sequence described. Use your list to determine if two formulas represent the same geometric sequence. Assume that a sub n represents the nth term of the sequence. So a sub n is equal to 2 times 5 to the power of n minus 1. So a sub 1 is going to be 2 times 5 to the 1 minus 1. So I think that's 2 times 5 to the 0 power. So that's 2 times 1, which is equal to 2. And that's your first term. So to find your second term, it still is this formula right here. So you go 2 times 5 to the 2 minus 1, which is 2 times 5 to the first, which is 2 times 5, which is 10. Okay, first 4 terms, right? So here's the third term, a sub 3. So it's going to be 2 times 5 to the 3 minus 1, which is 2 times 5 to the second power, which is 2 times 25, and that's 50. And then the last one, a sub 4 is 2 times 5 to the 4 minus 1, which is 2 times 5 to the third. Now 5 times 5 is 25, times 5 again is, I think that's 125. Let me check my calculator. 5 to the third power is 125, so 2 times 125. Well, you double 125 and you get 250. There we go. Explicit formula. You got to just plug in whatever n is. It's the first term, n is 1. It's the fifth term, n is 5. Alright, so recursive formula, that's when we need the previous numbers to get this current number. So we know the first number is 10. Now to find the nth number, you take 5 times n, a to the n minus 1. So that's a number before a sub n. So there's the first number is 10. So to find a sub 2, the second number, that's going to be 5 times a sub 1. And we know that a sub 1 is 10. So a sub 2 is going to be 5 times 10, which is equal to 50. That's the first term. The second term, a sub 3, is going to be 5 times a sub 2. So that's going to be a sub 2 is 50. So 5 times 50. So 5 times 5 is 25. Add the 0, 250. All right, we find the fourth term. All right, let's do it. So that's going to be 5 times the third term. So the third term is 250. And 5 times 250 is equal to 1,250. There we go. Okay. Oh, sorry about that. Okay, now you can see it. All right, so now what? Explicit formula. A sub n is equal to 64 times 0.5 to the n. All right, let's find the first term. A sub 1 is going to be 64 times 0.5 to the 1 power. Well, that's just 64 times a half. So that's just half of 64, and that's going to be 32. All right. The second term, it still is 64 times 0.5 raised to the second power. So that's going to be 64 times 0.25. So 64 times 0.25. That's a quarter of 64, and that's going to be 16. That's a second term. I think we're supposed to find what? 4 terms? Yes, find the first 4 terms. All right, fine. So the a sub 3. Actually, do you see the pattern? That's a 0.5, right? 0.5, 0.5. So that's the decay factor. So 32, 16, isn't that half of 32, 16? So if you know the pattern, you just know half of 16. I think that's going to be 8. And then half of 8, that's going to be 4. And then half of 4, that's going to be 2, etc., etc. Okay, that's easy. And then the recursive formula, that's your first term. And to find the nth term, you go 0.5 times the term before that. So that's just half of the previous term, right? So to find a sub 2, you're going to go 0.5 times a sub 1. So that's 0.5 of 32, and I think that's 16, because half of 32 is 6. No, is it? Yes, it is. All right. And then a sub 3 is 0.5 times a sub 2, which is 0.5 of 16. So half of 16 is 8. And then a sub 4 is 0.5 times a sub 3, the previous term. So that's going to be 0.5 times 8. Or 4. But you probably see this. So a sub 5 is just going to be half of that. A sub 6 is going to be 1. A sub 7 is going to be 0.5. You get the idea. Just divide by 2. All right. So we rocked the first couple pages. Let's go to the third page, number 13. I hope you're still with me. Hope you're learning stuff. The test is tomorrow. All right, given the explicit formula, how can you solve for the nth term? So given the explicit formula, so let's say that a sub n is equal to, I don't know, 3 times n plus 5. So to find the nth term, a sub 10, you just go 3 times 10 plus 5. And that's equal to like 35. So the nth term, whatever n is. So anyway, you just, like explicit term, you just, whatever term you want it to be, you just plug it in. All right, the table below shows the value of Alan's home over a 4-year period. The equation is this. Describe the curve of the best fit for the value of his house. Let x represent the number of years since 2002. So that number is the original value. That means, wow, Alan's house is worth $250,000. Lots of money. Now that number is the growth factor. It's bigger than 1. So it's growing at 8% per year. So the first value has to be, what are we, that's 2002? So what are we doing? Equation of election. Okay, so it starts out at 450,000. And then I think we multiply by 1.8, we get that. That's 8% increase. multiply by 1.08 again. It's now that. 5th year, wow, house is now over $500,000. So use the equation. What would be the approximate value of Alan's house in the year 2007? So I think this is when it's at the beginning. That's year 0, right? A year later, 2 years later, 3 years later. So 4 years later, it's 2006. So 5 years later, it's 2007. So that's 5 years later. So the formula is 450,000 growing at a rate of 1.08, and we just raise it to the 5th power. So if you don't know how to do this in your calculator, it looks like this. Calculator. It's 450 grand, and then you do the multiply. Now this is assuming you calculate in Sam's order of operation. Then you go, what are we doing? Oh, 1.08, and then you do that caret thing, and that tells you it's an exponent. It's to the 5, and then there's it is. Alright, so 450 times 1.08 raised to the power of 5. And that's 661,197 point some cents. So really, we're talking about in the year 2007, Alan's house is worth $661,197. That's a lot of money. Okay, what's the equation of exponential growth? Oh, well, I think that's just y is equal to a times 1 plus r to the t power, where a is the initial number, and then r is the percentage of increase. But remember, this r is always in decimal. It's always in decimal. So to find decimal, well, you just click it to the left. All right, number 16. Mrs. Gardner's stack of grading contains 320 papers and growing by 10% per period. Write an equation for how much she's grading. Poor Miss Gardner. So y is equal to, it starts out with 320, and then it's 1 plus 10%. Now 10%, 2 decimal points to the left, and I guess p for period. So y is equal to 320 times 1.10 to the p power. So whatever p is, you add that number and you work it out on your calculator. That's fine. All right, number 17. Number 17. Max suspects the function he created to predict the attendance of his graduation party is flawed. He suspects the function he created for the predict the attendance of his party. His data indicates the population begins with 20 guests and grow by 15% per hour. His prediction function is going to be this. After h hours, what's Max's error? Well, I think it's just y is equal to 20 times 1.15, that's 15%, and then it's to the h hour. So what's the deal with that minus 1? He's trying to click it 1 hour to the right. So 1 hour to the right. I think he's speeding it up by another hour. So I think there is his correct answer. Explain his error and the pieces he had correct. So the error is that I suppose that it should be just h instead of h minus 1. All right, number 18. Number 18, the graph above represents the sales in thousands of dollars for two companies given the number of years they've been in business. Label each line curve above the linear, exponential. If both companies continue to grow at the current rates, what would be the most sales by year 10 in business? So the straight line, of course, is a linear function. Maybe I should use a straight edge, right? Yeah, I found a straight edge. Do I not have an ID card around? Where's my ID card? I don't know what that is. Alright, whatever. And then here is the exponential. So you can see that the exponential finally catches up over here. Now, he caught up over here, so what is the year here? Read that 1, 2, 3, 4, 5. So maybe on the 6 years it caught up, and then how much money are we talking about here? So what is that? 3,000, 5, 1, 1,500, 2,000. So each of this is like, so that's 3,000, so that's 3,500, and then that's 4,000. All right. So they intersect at year 6, and they're both making $6,000. But after year 6, you can see the exponential growth is going to be way, way faster than the linear growth. You can see that's a big difference in increase. So in 10 years, well, this is already year 6, so the exponential increase in 6 years. So in year 10, the exponential increase will, so in year 10, exponential curve is bigger. But you can see that in year 0 to 6, linear is bigger. I don't know if bigger is the right choice of word, but certainly there's more money. You can see at the beginning they started out about the same. A year later, that's linear, and then that's exponential. You can see there's a big increase right there. And then here is year 2. There's a pretty big increase. Oh man, you can see in year 3, this guy, the linear is getting way bigger. And then really big increase. And then now it's starting to get smaller and get smaller and get smaller. And now the exponential is bigger. So they trade places. All right. So in 10 years, the exponential curve will have the most amount of money. Oh my goodness. Almost done. Okay, evaluate each expression. Now this, I think I can use the exponential rule. No, not the, what is it called? The power rule. So that's going to be 9 to the 1/2 times 2, or 9 to the 1, or nothing. Okay. This one, same base, we add the exponent. So it's 9 to the 1/2 plus 1/2, which is 9 to the 1, or 9. Wait, I think it's all 9? That's interesting. And then with this one, it's 9 to the 1/2 to the 2 times 1/2. Now, we did this one already, so that's just going to be 9. And 9 times 1/2 is 9 over 2, or 4.5. And then this one, we're just adding. We're just adding, so we have to evaluate this. So this means it's the square root of 9 plus the square root of 9. Which is 3 plus 3, or 6. So which equivalents? I guess these two are equivalents, aren't they? So 9 to the 1/2 to the second power is equal to 9 to the 1/2 times 9 to the 1/2. Well, that's exactly what it means, doesn't it? Right? It just means it's 9 to the 1/2, and then 9 to the 1/2 again, because there's 2. Anyway, so these are equivalent statements. And that is the end of the review. The exam is tomorrow. I hope you do well, and if you don't, well, you can try it again. All right, bye kids.